your decision trees and your other type of root cause analysis tools. But at the end of the day, step back and look at a problem holistically and try to look at different ways that haven't been done before to solve something. Ability to think logically, again, I think engineers are just geared to be logical. It's just such a critical factor when you're making decisions on how to design a product. I always try to use common sense, so an example for me would be over the years is I'm looking at trying to fix problems. Earlier in my career, it was, there's a problem, okay, put whatever money you want towards it, no big deal, there's not a budget. Like, engineers were not responsible for their costs, right? And then they said, you know what, an engineer should be judged upon how they solve a problem. Hey, did I put 20 bucks towards it? I did $20 to a vehicle. Yeah, I solved the problem, but my profit margin just went down to like nothing, right? You figure $20 per vehicle, and you sell 300,000 vehicles a year, that adds up, right? When we're dealing with parts, we're talking nickels, dimes, so if you go up 25 cents, that's a big deal. So the engineer now has to look at a problem and be more creative and say, I just can't put $5 towards this. I need to do it as cheap as possible, but still have the same quality. And I am judged by that in my performance review. It is expected that I am a creative engineer. I think logically when I look at how to do a root cause analysis, come up with a solution, and offer that to my chief engineer. So again, common sense and logic is very crucial for any industry you work in as an engineer. Okay, mathematically inclined. All engineers are mathematically inclined. I always thought if you want to major in math, you would just teach math. So over my experience, I found that if you really want to be in hardcore derivatives and get a PhD and be a modeler. Most of the people at Ford that I see work on developing very sophisticated models. I would give them physical test data, and they have all these equations they're coming up with and putting into this model. To them, math is so critical. In my job, I have never really used anything outside of statistics, which I went through Six Sigma training, and statistics is a great tool. But for an engineer, hardcore mathematics like derivatives and advanced math, you want to kind of be more in the computer space if you really want to take advantage of that. Problem solving skills, again, that's just kind of goes without saying. To me, team player goes again with communication. If you do not respect the people that you work with, if you do not communicate well, you will not succeed. Auto industry, defense, it doesn't matter. Today's world is set up, you can even tell that Ford is putting $1 billion in to knock down their entire campus and rebuild their entire campus in 10 years. But they're basically going with the trend. Every other big company is that, new type of workspaces, whiteboards, there's no walls, no cubes, tables. They want to bring people together because that is how you solve problems. So, you need to be open to working with all walks of life, respect your opinion, and that's just kind of the future that all companies are really going towards in the future. So, and then technical knowledge, again, as you progress in your career, as an engineer, you may not know exactly what you want to do. So I would encourage you to, if you think you want to be the auto industry, get an internship in that, give it a shot. If you feel that you want to try the tech industry, get an internship and give it a shot. But I think the earlier that you can figure out kind of what part of engineering you want to work in and get the experience will just be beneficial to you. So.
Yeah, by the time when I was where you guys are right now, I had already been working for 9 months. So this perspective.
Okay, so what makes a good mechanical engineer? I mean, when I was a kid, I basically liked solving problems. When I was in the Boy Scouts, I liked working on pine cars to race how to make it more aerodynamic. As I went in high school, I just enjoyed solving problems. To me, a good engineer is someone who likes taking on challenges, identifying what the problem is, and come up with really cool ideas. Whether it's a new technology or a creative solution to something someone hasn't been able to do. To me, that's really the drive that makes a great engineer. So I don't know, I guess I would say about 2 months ago, I was lucky enough to go out to Pebble Beach for the AT&T Pro-Am. We're doing a joint venture with Microsoft. And you know, I had a chance to meet people from tech industry and other, you know, the auto industry, but more like the tech space. And it was really cool to see that, you know, when people work on what they're working on, it was a very universal. I want to make a difference. Like, I want to impact something that touches at least 1 million lives. I will admit the auto industry does not think like that yet. They're kind of getting there, but the tech industry is very big on making a difference and making an impact on this world. And I think as an engineer, you have such a great opportunity to, you know, be a part of that, whatever industry, whatever type of engineer that you want to be. So, okay, so what kind of jobs can you have as mechanical engineers? I mean, there's a lot of things here, but you want to work in auto, aviation, mining, tech. You know, there's pretty much unlimited industry what you want to do as an engineer. These are just some examples of construction, chemical, auto, aerospace. But like I said, the earlier, if you have an idea of what you want to do, you know, try to pursue. And it could be going on LinkedIn and finding people who work for a company that you're interested in, just to kind of say, I'm curious to know what you do. So if you want to do a tech space, you know, try to find someone who works at Apple or Google. If you want to find someone who works in the auto industry, talk to us, GM, Toyota. You know, the more you learn, the better informed you can be to decide what area you'd like to work in. Now, I know Michigan is auto industry, and you know, everyone works at the OEMs or suppliers, but I think that Michigan is even growing to be a little more diverse for BME. But you know, be open outside of just this immediate area and think bigger. Because I remember when I went here, it was always like work at the auto industry. That's what everyone did. It was not like it is today. So I'd really encourage you, if you're thinking about, or if you're hesitant on doing something outside of your comfort zone, I'd say do it, because you're young and you won't know until you figure it out or try it. So. Okay, so these are just different types of engineers at Ford. So transmission systems. I have learned that to design a transmission is probably one of the most complicated things that someone could possibly do. When you want to make a V8 have the fuel efficiency and the feel, or V6 have the fuel V8 have the fuel efficiency of a V6, and you know the way it shifts, it's very challenging. Most people I know who work on transmissions have PhDs, and it is job security. When they explain to me what they're doing and the challenges they have, I just kind of like glass eyed after a while and just say, I respect that. I don't really want to do that. But again, it is a very challenging product to design, improve. So just, yeah. Okay, some of these have detail. I'm not going to get into that. I want to kind of give you an idea of just roughly what kind of engineers we have, like axle structures engineer. So how this would work, let's say, you know, the next F-150 that we're working on, we're just in the initial planning stages of it. You know, we look at what customers want for weight and torque and pull. And I'm gonna basically go to an axle engineer with saying, here's a bunch of customer data, this is what they wanna do, and this is the current model doesn't do that, right? So we need to increase the, you know, engineering specification on this to our suppliers or internal design. Please go do that. Right, so they're going to be doing a lot of CAE, FEA analysis on axles, and they'll be doing a lot of component lab testing, which will eventually lead to full vehicle testing that literally puts a vehicle on 4 individual pillars and literally moves this vehicle in very strenuous up and down, a lot of high frequency, high duration testing. So, you know, the axle engineer gets the information from me, from marketing, does all the FEA analysis, talks to the supplier, they work together, develop a prototype, works with the application engineer, and then kind of goes from there. So, okay, supplier technical assistance. So this is kind of an engineer that is responsible for a certain commodity at various plants. So let's say I'm a supplier technical assistance engineer for Ford, and I own all the powertrain plants that are not Ford in Mexico. So basically, any powertrain that comes out of a supplier plant that goes to one of our body assemblies, I'm saying it meets all engineering specifications from the process FEMA, all the manufacturing specifications, there's no issue. So if I have a field problem and I actually need to go to a supplier plant to diagnose a root cause, I've had to go to Mexico multiple times to literally go look at an assembly line and I know what I'm looking for a root cause in a part, and I will find it, and then I work with them to make sure that the assembly line is updated and that station is fixed, so we kind of fix the problem. Also, take an example, when I was developing a new technology, I was in a joint venture with Eaton Corporation next door to develop a valve that was allowing a sealed pressure tank to slowly leak out into a carbon canister when it was either high heat or high vacuum. So the problem was, there was no assembly line. So my job was to go down with this STA and put the line together in Reynosa, Mexico. So, I went down there 4 times, literally put the machines, put the floor. So at the end, I basically have process FEMA. I'm walking this entire thing from all the material that comes into plant, how it's shipped to the line, walk every station to make sure I can't build it wrong, how it's stored, and how it's shipped. So I would work hand in hand with the supplier as a technical engineer to make sure that was done correctly. So, okay, hybrid vehicle team. So being a package engineer, I think just being on a hybrid vehicle team is a lot of different things. So if you want to work on electrification for batteries, that is a very big space right now. So we have batteries for a plug-in hybrid, a full battery electric vehicle, a regular hybrid, a mild hybrid, and a start-stop technology. So these are all technologies that we are investing lots of money in. They're going across cars. And so as an engineer, you have an opportunity to kind of work on all those different things to support hybrid. And right now, hybrid is very important for us because one of the biggest challenges we have at Ford is to meet fuel economy regulations in all different markets. So in 2018, Europe has a new requirement that we have to be more fuel efficient for all vehicles. 2017 for Europe. So as a strategic planner, one of the things that we do is we take a gas vehicle and we are going to add an electrification derivative to it, because we don't make any money doing that right now with the level of technology of battery and whatnot. But what it does, it allows us to sell the vehicle in that space. So it's going to cost me $2,000 to take a gas vehicle and make it a PHE derivative. I can get $500 return on investment in that. Now, if as an engineer you can make that battery smaller, cheaper, it means it helps me make more return on my investment when I have to do that. So a lot of challenges right now as a hybrid engineer.
Question?
Quick question, just
Yeah.
currently with current market trends, do you guys see that the electrification of vehicles will be more profitable or more in demand than just